So here we are being asked to identify those key characteristics of a quadratic function. And looking at the graph, I know it's a quadratic function visually just because we have that u. And the u is what we call a parabola. So looking at a parabola, and remember parabolas will open up or down, not side to side. We're up and down, and it is opening down. And we need to figure out, okay, what information can I get from this graph just looking at what we have without having an equation? So the first thing I want to find is the vertex. Remember, the vertex is the very bottom or the very top of a parabola, depending on which way it's opening. And so here it would be the very top. So my vertex is right up here. If I have a vertex here, I'm going to go ahead and name it or give it a location. And we do so using an ordered pair. So looking here, my ordered pair would be, looks like -3, 7. So we just sort of think about, okay, where are we at here? -3, 7, and make sure you have it XY. So in our first box here, we would type it in, and they are typed in as an ordered pair. So you'd have to use the parentheses, comma, has to be there, no spaces. And then what we have is called our axis of symmetry. Now, if we have a perfect U shape, it's kind of like a butterfly, we have something that is perfectly symmetric, that means that we can divide it right smack in the middle. That's what the axis of symmetry is. The axis of symmetry is this line, and it's invisible. So since it's invisible, you will notice in all your notes and on your assignments that it's drawn with a dashed line or a dotted line, because it's not really there. We're putting it there so we can see it, but it's not part of the quadratic. It's just to help us understand the graph a little better. Now, it is invisible, and it is a line. It's a vertical line. And if you think about vertical lines, that would go all the way back to when we talked about that word vux. So VUX, x equals. What type of line is this? Vertical. So the equation for this vertical line would be x equals, and it's -3. So it's always going to be the x value of your vertex. So the next thing it asks us to do is, does it open up or down? And, well, this is going to open down. And it looks a little different here on my page because it brings it down to the bottom. So we would mark it as it opens down. Is it a maximum or a minimum? Well, to be a maximum, it needs to be at the top. To be a minimum, it needs to be at the bottom. So this is at the top, so that would be a maximum. And then it says the value of the max or the min. So the value of how high or how low this parabola goes. So think about that. How high or how low? How high, the top, the very tip top, is right up here at here. This is as high as it goes. So the value is the y value of the vertex. So the max, and this is going to be a max, right? Because it's opening down, so the very tip top. So the max value here is 7. Very high, highest point. We don't care side to side. Max and min are all about up and down. Then we have number of solutions. Number of solutions. Solutions are all about where does it cross the x-axis, how many times. So if I look here, it crosses once here, crosses once here. Number of solutions, 2. We'll talk more about that coming up, but for now, we're just going to say 2. It says C. Oh, my page is over here. We go. So B2. We need to know the y-intercept, and it says it does not apply here. And I'm like, why not? Well, look at your graph. This particular graph doesn't show us exactly where it crosses, so in this particular problem, we're not going to have a y-intercept. This is the only problem like that in this assignment. Every other problem will cross the y, and you'll be able to put that in. And then we ask for the domain, and you see it's a drop-down menu, domain, all real numbers, or no solution. Well, do you remember back in functions when we used the vertical line test? We would start on one side and we'd work our way around. We go, okay, so if I take my pencil and I move it across very slowly, will it ever go and cross more than once? And the answer is no. So remember, all parabolas have the same domain. They're all real numbers. Now, little disclaimer here, word problems have their own domains and ranges because they're limited by real life situations. But when we are just drawing a quadratic, that's not the case. It also wants to know the range. So the range, what are my y values? How much area is it covering? So I look here, the range, well, it's a max, so I'm going to go to my vertex, and I see that the range is all about the y, so it's all about the 7. And my parabola opens down, and it's going to go forever in that direction. It's never going to stop. That's what the arrows at the bottom tell me. It's never going to stop. So this means that any y value that's less than or equal to 7 is in this graph. So my range here would be y is less than or equal to 7. So that walks you through question number 1.